Welcome everyone. Let us look at problem 3.7 from the textbook. It states that at a point in a strained material, the principal tensile stress across two perpendicular planes are 80 Newton per mm squared and 40 Newton per mm squared. Determine normal stress, shear stress, and the resultant stress on a plane inclined at 20 degrees from the major principal plane. Determine also the obliquity. What will be the intensity of stress which, acting alone, will produce the same maximum strain if Poisson's ratio is 1.4? Now there's a diagram which is also given. Let us just draw the diagram quickly. So you have got a stress in this direction, and mind you, both are tensile stresses, so it makes it easy for us. All right, and he says there's a plane. Let this be A, B, C, D. All right, there's sigma 1. This is equal to 80 Newton per mm squared. This will also be sigma 1. This is sigma 2, which is equal to 40 Newton per mm squared. Now, there is an oblique plane coming from C, which is at an angle of 20 degrees. Okay. Now let us record what is given. Sigma 1 is given, which is 80 Newton per mm squared. Sigma 2 is given, which is 40 Newton per mm squared. Theta is given, 20 degrees. He's also given Poisson's ratio. Mu is equal to 1 by 4. We know Poisson's ratio is the relationship between lateral strain and longitudinal strain. So we'll use this going down. Now, what is he asking to find? First of all, he's asking us to find the normal stress, shear stress, and resultant stress on the plane. These are straightforward. Normal stress is sigma n. You've got your formula. Sigma 1 plus sigma 2 by 2 plus sigma 2 minus sigma 1 by 2 cos 2 theta. Substituting the values, 80 plus 40 by 2 plus 80 minus 40 by 2 cos 2 into 20. Solve this. 120 by 2, 60, plus 40 by 2 is 80 minus 40 is 40, by 2 is 20, cos 40. Put these values in the calculator and you will get sigma n as 75.32 Newton per mm squared. This is your sigma n. Now, he's also asking you to find out the shear stress. Shear stress on the plane is given by sigma t, which is equal to sigma 1 minus sigma 2 by 2 sine 2 theta. And substituting the values, 80 minus 40 by 2 sine of 2 times 20. It will give you 40 by 2 is 20 sine 40. Now you will get this value as 12.865 Newton per mm squared. This is sigma t. Now he's asking you to find out the resultant stress. We know resultant stress square root of sigma n squared plus sigma t squared, which is given by root of 75.32 square plus 12.865 12.865 squared. Punch that in the calculator and you will get 76.4 Newton per mm squared, which is sigma r. Right? That's part of the question. What is he asking? They are asking you to determine the obliquity, which is tan phi is equal to sigma t by sigma n. Now, if you substitute the values, where are the values? What will you substitute? Yeah, 12.865 by 75.32. This is tan phi. Now, phi will be equal to tan inverse 12.865 by 75.32. So your answer will be 46, sorry, not 46, 9 degrees 41 minutes. Okay, now he's asking another question in the end. He says, determine what will be the intensity of stress which acting alone will produce the same maximum strain if Poisson's ratio is 1/4. So supposing this takes us back to he wants us to estimate a single stress. So the effect of these two stresses we want to find on the single stress. Now, it is very important to understand if there is only one stress acting on the major planes, there will be a compressive load on the other two sides. So the effect of that compressive load, let sigma be the stress that will produce maximum strain. Same maximum strain. All right, so maximum strain will be equal to, now the strain due to both the stresses, sigma 1 by E minus mu sigma 2 by E. Now this mu is the relationship between longitudinal and lateral strain. So we are converting this lateral strain, sigma 2 by E, into its longitudinal impact or effect. That is why we are multiplying it by mu, which is Poisson's ratio. So this gives you 1 by E into sigma 1 minus mu sigma 2. Now, once you substitute, you'll get 1 by E 80 minus 40 by 4, which will give you 70 by E. All right. This is maximum strain. Now, the strain due to stress sigma will be equal to sigma by E from our definition of, or the relationship between strain and sigma, stress given by the Young's modulus. Now, these two, let us take this as 1. Let us take this as 2. The question states that 1 should be equal to 2. So equating these, 70 by E is equal to sigma by E. So your sigma will be 70 Newton per mm squared. That's your answer.